the modularity, the cleanliness of the cables, 2 blades. There's like a lot of things I do like about this design, and I think it will work great. In the previous part of IndyMower project, I designed a mower completely from scratch with very DIY materials and made it remote controlled. Then it was automated with a perimeter wire, which worked surprisingly well. I also discussed perimeter wire versus GPS RTK. But as I mentioned in my previous video, I'm deeply dissatisfied with this project, unfortunately. And that's why in this video I will design it from scratch to make it as cool as I can. Quick warning, this video will be very interesting. It will include CNC machining, making custom PCB, electronics, soldering, a lot of programming in Python, and finally great results. It is recommended to watch it till the very end. Thank you very much. Let's start with a good news, because one of my viewers reached out to me and mentioned that he has a broken mower that he can send me. I can do whatever I want, disassemble it, fix it, whatever. So of course I accepted the offer and I took a very deep look inside such a mower. It was very interesting. I definitely got some notes from that I will implement in the IndyMower, but of course IndyMower, a DIY project like this one, cannot be designed in the same way as a professional product. It's like a completely different thing to do these two things. But it was very interesting to take a look at the mower, and I was able to fix it because it turned out that a part of the PCB was damaged from water, so I replaced a few components. And it worked almost. There are still problems, and that's probably a topic for another video, but it works. So thank you very much for your support. To the viewer that preferred to stay anonymous, so of course I will respect that. Let's start with the old design. I wasn't happy about its size, the dimensions and overall look. Also, one wheel in the front was definitely a bad idea, so I will go with 2 wheels right now, slightly bigger wheels in the back, and the whole mower will be a lot bigger. I also decided to separate it into 2, let's say, modules, the front one and the back one. And these parts were made out of OSB on a CNC machine. In the future I'll replace it with something more durable, but OSB will work for now. It is very easy to machine it with a CNC machine like this one, and if you would like to build your very own CNC machine, check out industry.cc/indymill. It's an open source CNC machine that I designed some time ago. You can find all the parts and files that you need to build it on the website for free, and you can also buy some of the parts from my store and support my work. All the other parts that I designed were printed with black PETG on Bamboo Lab machines, my new 3D printers. And honestly, the difference from the time that I remember when I started with 3D printing, you know, like Ender 3, ANET A8, the difference is just so huge in how easy it is to use them, how fast they can print, and the print quality is just amazing. The assembly was very straightforward, just a few screws, aluminum profiles, printed parts, and everything just came together so nicely. Because the cut design, it was pretty good. I'm not bragging here, but I am pretty proud. It's simple, but it's effective, efficient, it's easy to modify thanks to the 2 separate pieces in the front and back. The aluminum profiles gave it rigidity. There is a lot of things I like about this design. That is quite a big improvement from the previous version that looked like this. Six or 7 years ago, it's been a long time, I used this saw to cut aluminum profiles for the Dremel CNC, and I still have it, I still use it, and it still works. And here comes the biggest difference between IndyMower previous version and IndyMower current version. This one will have 2 cutting motors, 2 cutting wheels, and 3 blades on each wheel. With this, I hope it will be a lot more efficient because it will cover a bigger mowing area. And while I know there are different mowers, automatic mowers available on the market with multiple cutting wheels, this solution is not that popular. And I'm just interested in how it will work. Thanks to aluminum profiles, these are easy to attach, so if you want to go with just a single motor, no worries, you can do that as well. Now the question is, should they both spin inwards, outwards, the same direction, and should it be left or right? I don't know, but we'll have to test it later. When you look at both of them at the same time, the first one looks a little bit like a toy, but as I said, it was a prototype, and actually it was a prototype of a prototype, and what I have now is a prototype. I know it's a bit complicated, but the version that I build now, I'm really happy about it. Designing the new mower, printing all the parts, machining, assembling, and all of that, that was fun, that was easy and enjoyable, but here comes a bit harder problem, the electronics. It's definitely too late to think for me, but I found how to create the perimeter, the envelope detector, not the perimeter, the envelope detector circuit. And it works, so now I don't have to calculate the frequencies with the Raspberry Pi Pico. I can just measure that with an analog pin, which will be way easier. And here is the simplified small generator circuit. In the previous part, I used the detector and a special program on the Arduino that was detecting the frequencies in the perimeter wire and then calculating the strongest one and then choosing that. And if that happened to be 5 kilohertz, it's a complicated thing. I don't want to use it ever again because I think there is a lot easier method, and that is the envelope detector. It's basically just a capacitor and a resistor, and well, that's it. It's how you can detect a specific frequency if you have a filter before that, and now I can just read the value with the Raspberry Pi Pico on the analog pin without any sophisticated programs, algorithms, and so on. But no worries, that wasn't the end of electronics related problems, because now I had to somehow organize all of that together, connect and make it reliable, so that after driving for hours on the grass, it will still work. Therefore, using breadboard was not an option, so I thought, well, let's try protoboard. I did it in the past, it shouldn't be that hard. When working on my projects, there is a lot of CAD design, electronics design and programming involved, and that requires me sitting in front of the computer for a very long time, which I honestly do not like because I know it's not healthy for me. But thanks to the sponsor of this video, FlexiSpot, this time might be a lot more enjoyable. FlexiSpot is manufacturing high quality electronic standing desks, and thanks to that I can easily go from sitting mode to standing mode in just a few seconds. They have a very nice display where you can save your positions and just press a button to go to a predefined position. It's very easy to use, and that encourages me to use it more and to switch my position between sitting and standing a lot more often. You can configure your desk however you like. There are a lot of different sizes, colors and materials available, and their desks are very sturdy. Even though I have a heavy setup and I often keep parts of my projects, which sometimes are quite heavy, the desks handle it without any problems. They also have a lot of nice accessories, for example a cable chain with which you can easily organize all of your cables and make the setup super clean. They now have a fall sale, so it's a good opportunity to get yourself a nice desk and save some money. Check out FlexiSpot for a link in the description, or use this code when placing an order to get a discount. Remember that supporting the sponsor of this video means also supporting me, so I would really appreciate that if you check out FlexiSpot, link is in the description. And now back to the video. I just spent 15 minutes trying to solder two cables together to one pin, and it didn't work. And I think I'm done with the protoboard approach. It's time to design a proper PCB and make it with a CNC machine, because otherwise I will go crazy before finishing this thing. It's so stupid. It takes so much time. It really was that hard. After soldering just 10% of this board, it already was a mess and I had no idea what's going on, so I decided to leave this and do something completely from scratch. I designed a PCB in KiCad, first in the schematic, then PCB layout, and I wanted to machine it on a CNC machine, which I already did in the past, and I know how to get it working. The problem is that CNCJS, the software that I'm using to control my CNC machines, does not have a height map feature, which is kind of essential if you want to get a nice PCB, but I found a plugin on GitHub that you can connect to CNCJS, but it was super tricky to get it working. I finally did, and if you would like to do the same, I created an article on my website that you can read. There will be a link in the description and you can go through all the process. And I'm probably talking right now too much about this specific detail and it is getting boring, so let's move on to the next step. Okay, auto level, let's try again. Yes, this time it works. I converted one of my old small CNC machines to be used for PCBs only, and it works kind of well. Of course, you cannot machine super thin traces and it's not super precise for like very tiny SMD components, but for THT only or some resistors, it's definitely good enough. I don't even remember how many times I did this mistake of not flipping the PCB for CNC machining. And the worst part is I remember to do it this time to check. And I was certain that everything is fine and I do not have to flip it because it's already flipped. It wasn't, of course, it wasn't. So yeah, this thing that I just started machining and prepared everything and stuff. This will go to trash because you cannot like reuse it for any other PCB. Fortunately, laminate is not really that expensive, so that's not a big problem. But again, I just wasted a lot of time, so... It took about an hour to machine the complete PCBs, and of course I designed all the G-code files with Flatcam, which is like a software that converts the Gerber files to G-code files. It's a bit hard to use, but once you like make a few PCBs, it becomes kind of obvious how to click everything, and it really works. It's open source, it's totally free. I definitely recommend this software. The biggest problems with these PCBs made with a CNC machine is that when it is done, it's not really done because you have to put it under a microscope and go through all the traces and check if there are no any problems, no copper is touching between the traces and so on. For example, yeah, like here you can see we have a bit of copper. Is it a problem? You need to measure that with a multimeter and eventually use a knife or like a screwdriver to remove it. It's a bit of work, definitely, but it's doable. And honestly, I think I prefer that over the protoboard. Also, for this project, I used Raspberry Pi Pico. Previously, I was using Arduino, but I just like the Raspberry Pi Pico so much because it can be programmed in Python, which I really like, and they are inexpensive. And here I used the version W, which also has a Wi-Fi, which will be very useful in a moment because I created like a little website that you can use to control the mower. While I still love Arduinos, Arduinos are great, the community is amazing, but Raspberry Pi Picos, I do like Raspberry Pi Picos. To safely measure the voltage of a 3S LiPo battery, we need to use a voltage divider, simply two resistors connected together and then connected to the analog pin so that the voltage is not higher than 3.3 volts. And to find these values, I thought, well, I will use ChatGPT, and I asked ChatGPT, here is the voltage that I will use. I want to connect it to a 3.3 volt pin, so calculate the values for me, and it gave me all the equations, all the steps, everything, and finally the values. And it said 28.2 kilo ohms, which you can round to 27 kilo ohms. But I'm not that stupid and I know how to calculate all of that, so I did my calculations on a piece of paper, and according to my calculations it's 2.8 kilo ohms, 10 times smaller value. But I'm not that stupid and I don't trust ChatGPT or myself, so I created a Tinkercad simulation. Here it is. Who was right? I was right, and ChatGPT is pretty stupid. It's kind of nice that this expensive technology, that is the future of humanity, there is so much hype around it and it will solve all of our problems, is still just so weak and so stupid compared to like a simple human being as me. Then I took my small Bluetooth label printer, which I totally recommend. It's not really that expensive and it's such a great tool in a workshop. I printed little labels that I sticked on top of the PCB. It took a bit of time, but it's definitely worth it because when you start connecting all of the cables, it makes it so much easier. I graduated from the university and now I have a title of Master of Data Science, which is nice. It took 5 years, it was a lot of work, but I'm glad I do have the knowledge of data science, machine learning, artificial intelligence and so on. And definitely in the future there will be more projects related to these topics, especially connected with robotics. I'm already working on something. It will be soon on the channel, so definitely subscribe to don't miss it. But the most important part for me right now is that I have a lot of time to finally focus on the IndyMower project, so let's get this version to work by connecting all the electronics. With all the new cables and organization of everything, it's getting more complicated and messy, and as long as it works, I like it a lot. It doesn't work anymore. I mean, the motors do work, the blades work, but I connected the perimeter wire sensors and something is wrong, like the readings on the analog pins of the Pico. It's like random values. I don't know how to fix it right now. It took me way more time than I wish it did, but I finally found the problem. It wasn't the software, it wasn't the connection. The amplifier I was using was faulty, and I just replaced it with exactly the same unit, just a different one. And now, well, now it works. In the previous part about IndyMower, I have been complaining that I'm deeply dissatisfied with the project and with the design, but right now I do like it a lot. The modularity, the cleanness of the cables, two blades, there's like a lot of things I like. And that is my new workshop that I built recently with my dad, completely from scratch. If you are interested, I might make a video about it, so here I will be testing it, mainly because of that. Here is the grass, and thanks to the shadow from the workshop, it is growing very quickly, and that will be perfect for the test, because I will be able to test it very often. So now I will do the perimeter wire here. The best part is I can control it with my phone. It's not an app, it's just a website running on the Raspberry Pi Pico that I can connect to via an IP address, and now I can control the mower. I can control it manually, but I can also press Start Mowing button, and when I do that, I'm actually not sure what will happen, because a second ago it wasn't working. I tried to fix it, so there is a chance that I solved all the problems, and now even the blades will work. It will detect the perimeter wire and just drive inside all the time. But there are still no blades on the wheels, so it is not going to cut any grass. But we will fix that in a moment. So far it did not escape the perimeter wire even once, which is pretty good. It is cutting very well. I think the speed is quite appropriate. The two blades are nice. It is a bit louder than I wish it to be, but it's fine. I mean, the most important part is it works. Look at all the grass. It is definitely going to cause some problems in the future. I will need to enclose the electronics in some waterproof box. I tried a lot of different methods, and I was pretty close to give up and actually tell you that I need help, and if you know how to do such a thing as following the perimeter wire, please help in the comments, but I think it just worked. Even at 90-degree angles, which you shouldn't usually do with the perimeter wire, it works. That is very surprising, but I'm also very happy to see it working. I am so happy about the test I conducted yesterday, because everything just worked as it should. The mower never escaped the perimeter wire, and even following the wire just worked. It sometimes escaped the perimeter wire when following, but that will be an easy thing to fix. And now I'm lowering the blades. And the test just worked. The mower works perfectly here. It always stays within the perimeter wire, and I have been just running it every other day for like an hour until the battery runs out. So far I'm using the LiPo battery, the battery that is often used in drones, because I just happen to have it, but I already bought 18650 cells. I think I have 12 of them, and these plastic connectors that I 3D printed to make this kind of battery pack. I also bought a spot welder to weld all these batteries. I have the strip. What I do not have is the BMS. I also placed my GoPro on top of the mower. I just put it on top, which wasn't a very smart idea. And then it was mowing, and suddenly the GoPro fall under the mower. And obviously the blades hit the GoPro, and that's the result of that. It wasn't that crazy, but you know, if you put your fingers in here, you really don't want to put your fingers in there. So safety is something I need to take care of in the future, because right now it's not really that safe, but also I'm using it only for like my own purposes. And I'm always present during testing, so nothing bad will happen. But of course, safety is something that I have to consider and somehow protect the mower so that it's safe to use when you actually build it. IndyMower is definitely not going to be finished this year, but hopefully spring of the next year I will finish everything, create nice documentation, and share this project with you, my viewers. If you like what you are seeing there, you can check out my other videos as well. You can subscribe to the channel, like the video, comment your video ideas in the comments, share this video with family, friends, whatever. It really helps a lot. Thanks a lot to FlexiSpot for sponsoring this video. Remember that supporting the sponsor means also supporting me and my work. So check out the link to FlexiSpot in the description. And if you would like to support me in any other way, so that I can buy expensive motors for the IndyMower and tools that I need to build different projects, check out all the links in the description. Thank you very much, and see you in the next video. Bye. There is also a link to industry.cc/IndyMower in the description, and if you want to learn more about the project and sign up to the newsletter, please do that now. Thank you very much. Bye.